Hi, my name is Ben Freed. I am the co-founder of Prosimo LLC, and we import European passive house windows. And I also am an owner of a net zero home, Upstate, that I built with the help of David White.
My name is David White. I have a business called Bright Environments, for which I do the engineering work for energy efficient homes, and I teach architecture students at the new school.
So, when we started looking for a house, energy efficiency was something on our mind. It wasn't something we thought was really attainable, but the idea was a passive house for $200,000. Can it be done?
So we wanted to make a net zero affordable house, and our core strategy for achieving that was to use post-frame construction because it's so low cost, and adapt that to high-performance construction.
The idea behind the framing system was pole barns, which are a really common way to put up a large amount of square foot as cheaply as possible. And so this mock-up here is trying to figure out if our insulation strategy would work.
We had already looked at a double stud wall, and I'd worked up details, so I was a little bit resistant to it. It was new and a learning curve, but it worked out great. I mean, we ended up getting a system that uses much less wood. In terms of the framing, it sequesters more carbon because solid wood sequesters carbon. OSB does not sequester carbon. And it was much less expensive than a typical frame wall. Because it used less wood, that meant less use of our forest resources, but it also meant less thermal bridging.
So yeah, it comes on a truck, and there are structural posts that go 8 foot on center, and bolted to the bottom of the posts are a precast, 5 foot long precast concrete column, and that just goes right in the ground on top of a precast concrete footer. So you just dig a hole in the ground, you put this, big post, you backfill it, and that's basically your foundation and your wall framing in one. And so there you see the secondary framing, which is a 24 inch on center 2x4s, just running flat vertically up the wall. So it goes up super fast.
And those 2x4 girts, they're upstanding, and they turned out to be strong enough to bear all of our windows. Girts with a 3/4 inch plywood going across become the sill.
So what happens is that you frame the whole house, and then you pour the floor. Because with a lot of these buildings, they don't even have a floor, it's just a barn. The framing actually provides the form of the slab, and we just filled it all with foam, and then we have foam pieces that went in between the posts.
We did a sort of nail-based panel of 1/2 inch plywood and 1 inch of polyisocyanurate in the same plane with the interior 2x4 girts.
Yeah.
And we poured against that. We got R6 in front of every post,
right.
So we were in pretty good shape.
Yeah.
We couldn't even see the posts on thermal imaging after on a very cold day.
Yeah.
So
the Solitex is going directly onto the top cord of the truss, and then 2 layers of 2x4s on top. The recommended install to sort of get the drainage plane underneath the metal roof. They figured out if they started at the ridge and just rolled up the Solitex, basically, staple it, and then come down to the next one, put it out, and tape it while rolling up, each course of Solitex, they could sort of get at it, tape it as they were coming down. I really just like this detail, and there we use the Nidac. It just feels great when you have your your water barrier underneath framing that is taped and secured, and no matter how many times you want to re-roof or how many screws you mess up on your roof, you're still perfectly watertight, which you can't say about a shingle roof that you're slamming in hundreds of nails right in through the sheathing.
This is an unusual attic design. It's an attic with loose fill insulation that is not vented. It stays dry by vapor diffusion through the drainage plane, and then the space above the drainage plane is generously vented. Right, we have 1.5 inches to 3 inches of air gap up there. So just to be clear, our interior air barrier was OSB at the ceiling, Intello at the walls, and then a poured concrete slab at the floor. The roof to wall connection is continuous.
Top course is actually coming down from the roof and continuing on with the wall.
We actually designed every single bay of the house specifically for a particular bat layout. So the sizing of the windows and the size of the bats, it was all designed to minimize the cutting of bats and minimize waste.
And that's the start of the installation process. So basically we have these 1.5-inch bats. We spaced the girts specifically with a 24-inch space for these bats, not 24-inch on center. So they ended up being 27.5 inches on center, because these bats are for commercial studs, metal studs, for air sealing. I decided to sort of really needed to take the air barrier into my own hands. And so we got the Intello and put it up, and at all the intersecting walls we had to tape it to the stud, the vertical stud going up and down, which was the only thing that made it kind of finicky, but just everything else about it was super easy, just rolling it out, taping it up, and then cutting out the windows and doing the pre-taped corners. For my work, I travel, so basically halfway through the construction, after the night before I was leaving, I was still taping. David came a couple weeks later to do the first blower door, and I was just like very nervously awaiting his call, but luckily everything tested out all right.
What did you get?
It was half an air chain, 0.5. By passive house method, and that's very low for a building, a single-story, single-family detached home.
The lack of any indoor contaminants is also amazing. I have people come over with asthma who feel just amazing after spending a night in the house. And we just passed our year anniversary, and we've made up all the power that we used from January to that July when we had the solar installed. The house without the PV was about $170,000 without the land. Total with everything is about $200,000. So we kind of met our goal. $200,000, passive-esque house. So
all costs, hard and soft.
Yeah, hard and soft. Design, engineering, pretty much everything in there. So it's a testament to how adaptable these different strategies are with the right products, and it was really successful. Yeah, during the process I just became really interested in building these houses, and I didn't want it to end with this project. So I started a company called Prosimo, and our first order of business is importing passive house windows. Energy efficient windows of vinyl, aluminum, wood, and just trying to get them here as affordably and efficiently as possible for as many people as we can. What I want to do with my company is provide solutions so that more people can enjoy these types of houses. Yeah, there's just a lot of potential to just completely change the industry. The only way to do it is to start something different, and 475 is doing that. Obviously no other materials vendor that would be able to provide that kind of a service. So
detail consulting,
yeah,
it's great.